So the syntax is a bit different for Volatility 3 since it's running on Python 3. So instead of image info, I'm gonna select windows.info. Okay, so we get the output now. As you can see, we have full information about the image or the system from which we have captured the image. And in the NT build lab, as you can see, this Windows 7 Service Pack 1, and this is the system root directory. Now, we proceed now and dump the process list. So in the old volatility, you can just find that by typing ps list. Now, in the new volatility, you're going to type -h one more time. See here, Windows, you have attached windows.pslist, as you can see. All right, so clear for windows.pslist. Okay, ps list. Now these were the running processes once the image has been captured. As you can see, we have a number of processes. Now, as always, we look through the processes and we try to find something that is not familiar or abnormal. So again, in the previous videos, we saw that some malicious processes or some malwares inject themselves into legitimate processes. In the previous example, it was the CSMSS or the CSRS. Now, in this example, it hasn't injected itself in one of the processes. It is obviously here the search indexer. Now, determining the malicious process right off the bat or immediately without just spending so much time, it requires a bit of experience, requires a bit of knowledge, and many encounters with these kind of memory dumps. So it's the search indexer here that is the malicious one. But we will not jump into conclusion right off the bat. We're just saying that we have search indexer, we have DWM, vbox tray. Okay, so we can inspect search indexer and we can inspect the DWM. Okay, so I'm going to jump back now here. I want to take more information about the process. I would just use LDR modules, API hooks. Okay, let's now list the running or the related DLLs of this process. So we take the PID, okay, and we type DLL list. So the associated or the corresponding command on the volatility 3, the DLL list, or let's do that. Grep DLL. So Windows DLL list. Okay. But since we are trying to find out the DLLs for a specific command, for a specific process, we would type the plugin name windows.dll list-h. So as you can see, we specify the PID, And if you want to dump the DLLs, we just type dash dash dump. So in this case, we have the process PID is, let's go up, search indexer 504. So dash dash, or first specify the plugin, which is windows.dll list dash dash PID, so 504. Just making sure. 504. Okay. So these are the TLS for this process. Services, process base. Let's just out again. So I have dumped, yes, 504. Right, these are the DLLs, as you can see. Now we can dump these DLLs to our local directory and inspect them with VirusTotal. As you can see, we have CryptBase, and we have seen most of the ransomwares use CryptBase to encrypt the files on the target system. What do we have else? And this is the path of every DLL. Okay, now we can choose to dump the DLLs with the option dash dash dump and dump them to the directory of the machine. Forensics, yes, unrecognized arguments. Let's check out the directory we dump, extract listed DLLs. Seems like we have to extract it on the same directory, or I don't know why it doesn't work like that. Okay, I'm gonna cd to the cd back, cd TryHackMe, cd forensics. Okay, let's run volatility from this directory. So take the full directory here, the Python 3, vol.py, and take the full command. No such file or directory. Okay, ls. So as you can see now, we have the dump of all the DLLs of this process. Now we need something else other than the DLLs. We need to extract the process itself, the executable file, and the process dump. We can do that in the old volatility. We can just, as you can see here, we specify the PID and the dump dir and the process dump switch. Let's find out if there is process dump switch in the new volatility. So this command, just type -h process. Oh, great. So we have on Mac, Linux, Windows. There is no Windows. Dump. Windows cache dump, dump files, hash dump, LSA dump. grab windows, temp files, get this IDs, man find, memory map. Seems like we're gonna stick with these two if you want to dump the, the processes. Okay, we know what malfind does. Windows malfind -h. So the PID extract injected VADs. Okay, we're gonna use this command. So in this command, we will just list the processes that have or that are injected, all right, and dump them to the directory for examination. So malfind, the PID was PID 504 and -- dump. Yes, we forgot the specifying the the image. So malfind -- PID 504 -- dump. Alice. So what do we have here? As you can see, we have dumped. These are DLLs. Let's see this like that. All right. So these are the processes that are injected. As you can see, the first one is explorer.exe, which is injected. The PID is 1860. The second one is also explorer. The PID was 860 to 11820, and this is also a Windows process. And the last one is WMP network 2664. So in total, we have 3 processes that are injected with malicious code. So we dump them. --PID, the first one, 2464. ls. So this is the process 2464. Now we dump the rest of the processes. Let's go up 1820, and we have 1860. So 1820 and 1860. So we have now the dumps of all the processes that are more likely injected with the malicious code. And we've also dumped the DLLs associated with a process that we doubt to be malicious. Now, what do we do next after we have dumped the processes that we think they are malicious? Let's see here, what do we do? We can also look at the API hooks. So let's see in Volatility, the new one, it has an API hooks -h hooks. API, no. Okay. Let's see what we can do more. Listing the network connections. So we can grep net to see what are the models or plugins for the network connection. We can use Windows scan to display the active network connections at the time of capturing the image. So commands will be like this. Windows.net scan. So let's see. Listening. So you see we have many processes on the listening mode, and these are the associated ports. So for example, um, this process, as you can see, it's not clear whether it is listening or not, but this is the foreign port it's connected to, and this is the local port. If you remember, this process was dumped or it has been injected with malicious code. So examining the ports it's connected to is worthwhile. Let's go down to 6. So for the same port every time, you see, it's connected all the time to the same port and listening on different port every time. The same port it's listening on the local machine, listening on 554 this time. All right. So now we have drawn some conclusion about what happened on the machine. We can just now start analyzing the files. So let's go to VirusTotal. Choose file. So let's start with the process dump of the these are the DLLs, I guess. Let's go down. All right. So we have 1820, 1860, and we have 2464. Let's start with 1820. So we have two. Okay, start with this one. Okay, let's answer some questions while this is being done in the background. Download the victim, downloaded. What is the OS of this dump? Just write OS name in small. So let's see. All right. So here I'm gonna just type again windows.info. So it is Windows 7 Service Pack 1. Incorrect. Just write OS name in small. How about some KDBT search? Maybe we need to put whether it is 64 or 86. 64. Start OS name is small. Win 7. Service pack 1. X64. Oh my god, what do you want? Win 7. Service pack 1. Maybe you only want Windows. What is the PID of search indexer? So we have seen that if we again type pslist, we've seen that search indexer has 504 as a PID. 504. What? What is the PID of search indexer? Let me check again. Oh, it is 282180. I just confused this with the other number. 2180. What is the last directory accessed by the user? Let's write the last folder name as it is. So it seems like we're going to use shellbacks plugin. Let's see if it is available in the new Volatility. It's not available. Windows, something equivalent. Seems like we cannot extract this from this version of Volatility. CMD line, DLL list, callbacks, cache dump, big pools. Let me see what is cache dump. Cache dump. Windows. Okay. Seems like we will not be able to retrieve this answer for this question because the module is not, the plugin is not available in Volatility 3. We have to install this manual. But if you are in Volatility 2, we can use shell backs and you will find the answer. All right, let's see the next question. Ask you, there are many suspicious open ports. Which is it? Protocol and port. Let's check this out. So we go back and we type windows.net scan. Let's go up. So you've seen previously that this process has been injected, right? And based on that, we were examining what are the ports this process is listening on and what are the ports it's connected to. As you can see, the local port is 5005 and 2464. And it's always the same. We go down 5504, 5505, and here the same remote port 2464, 2464, 2464. But every time it changes the listening port 5004. So the question here is, there are many suspicious open ports. Which is it? Protocol port. So the protocol is UDP v4 and the port is UDP v4 5005. Wrong. 2464. 64. Right, first one. Without v4. Okay. Then it is 5005. Okay. VATS, tag, and execute protection are strong indicators of malicious processes. Can you find which are they? So you're required to supply the PIDs of the processes that have VAT tags and execute protection, meaning that they are injected. So we've seen that if we type malfind, Windows malfind, so as you can see, the first one has VAD protection. It is 1860. The next one, 1820, and it has VADs. The last one is 2464. So 2464, 1820, 1860. 2464, 120, 160. Okay. In what order we require to supply the answer? Just wondering. Okay, let's start by order. One. Okay, 1860, 1820, 2464. So 1860, 1820, 2464. Okay, last one. In last task, you've identified malicious processes. So let's dig into them and find some indication of compromise. You just need to find them and fill the blanks. You may search them on VirusTotal for more details. So you don't need to download task files because we have already dumped we've taken dump of the processes. We're going to just proceed to analyze and extract the indication of compromise. And the first one is asking, write full URL without any quotation marks. We're required to search for this URL in the processes and find out the full URL. So if you go back, and what do we have here? These are the 4 dumps, 1820, 1860, and 2464. So we're going to type strings, take the first one, paste, and grep. So here, let's go back. We will need to provide a string that is to be grepped and contains some of these characters. So let's go back. So in this case, for example, grep google r.ru. Okay, Okay, so I extracted now the memory dumps using different command. So what we tried, you can just try memmap.memmap, all right, and it will list or it will dump the process, the corresponding process according to the PID. So you can use memdump for a full comprehensive dump. I tried pslist and malfind, but all of the dumps I got, namely these dumps, they don't. So using memmap.memmap, as you can see here, this command, I have been able to dump the full, I've been able to take the full dump of the processes, 1820, 1860, and 2464. Using only this command, I was able to take the full dump of the processes. So you can do that. You can issue this command according to the process ID, PID, and you can take the full dump of the process. Now, after we have taken the full dump of all the processes that we suspect the malware is, or the malware has attacked them or injected them, we can start now to look for indicator of compromise, IP addresses, domain names, whatever. So let's take the full process dump here. We can issue the command sudo strings. Yeah, it's ready. So basically, we're required to find. If you get back to the TryHackMe here, and nope, this one. This is okay. So here. So what we're required to do in the first process dump, we're required to find indicator of compromise for a domain name. Starts with go and ends with ru. So we have to use grep here and strings. We'll use string command and output the pipe the output to grep command and put here the full domain or snippets of the domain. Enter. So as you can see, we have a domain name that starts with www.go to it.ru. We can look for more domains. We can just omit the ru. So we have other domains. As you can see, many domains. So it seems like the process or the malware is trying to connect all of these domains. So we have ru here, ru. Okay, so let's see the pattern from TryHackMe. Go, we have 4 stars, and ru. So what we require to do here, we have more than one answer. So what we need to do here, we can get back and type 4 stars, which is 4 dots, and .ru. So we have 4 possibilities: Google ru, go for win, go caps, and go porn. So let's look at the hint. The site is a little naughty, so I would assume the answer is this one. Fine. Next one. Write full URL without any quotation marks. So we require you to find a pattern that matches this domain name. So again, we issue the same command, but this time, let's see how many stars we've got. 4 stars, indicating 4 dots. So it stands the same. The extension is .com and start with I. So remove the .com and here put I. So we have one match, which is I Kaka. Let's look for the hint. Do you like football? I would assume this is the answer. So these are all domain names that the malware was trying to contact. The third one is IC1234556.com. So IC, we have 456.com, 456. ICSA Labs. Let's try with this one. No. Hint, very strong indication of compromise. Dot, dot, dot. Okay. Now, the next questions, as you can see, we're required to find a pattern of IP addresses. So we issue the same command here, right? But instead of domain name, we would write the IP address. So the pattern here is 202, 3 digits, 233, 3 digits. So let's take this one and paste it. So I have one match, 202, 107, 233, 211. Of course, during an analysis, you would take the IP address and see the corresponding DNS name or the resolution of that IP, so you can get an idea about the identity of the attackers. The third one, or the next one, ends with 64. So replace this one. Nothing. Okay, let's modify this a bit. So we can, let's do this. Remove one star. No. Okay. Let's try with different process ID. If we try the 60, again we get no hits. All right. Let's check out the formula again. How about the third one, or the third process time? 26. Two six six four. No such dump file. 2464. So 24. Well, that seems tricky. I'm gonna take this one more time. Get back here. All right. So no hits. Okay. How about if we just see if 164 is there? We have many 164s, but this is not the correct way to find the IP address. But I want to know if there is an actual IP in the dump. Well, this one doesn't have, so let's look back at 120, 1820. 1820. We have IP addresses of 164, but it seems like none of them matches or match the correct one we're looking for. Seems like we have one hit. It doesn't start with 200. What's the start of the IP? So 200 at the second octet. No. One six four. So 200. dots. Let's put here 1, 2, 3, 3 dots, right? And then let's put backslash. So backslash okay, 200 and one backslash again. And here we put 3 dots for 3 octets. Okay, one backslash and 164. Let's see if this works. Invalid back reference. I have to just remove this like that. Number 3. Put 1 dot here and put 1 dot here. Oh, we have one. So HTTP 209.200. Let's try this one. Okay, it worked. Okay, the next one is 209.190. Let's first try with this form. If this doesn't work, we're going to use the previous one. And we have a hit. So let's take the IP. Last question, what is a unique environmental variable of the PID 2464? What is a unique environmental variable? PID 2464. So if we get back and issue volatility on the process PID 2464 or the PS list. I hope, okay, so here I'm going to move these and just type PS list. Grep 2464. So 2464, unique environmental variable. Oh, it is not. Let's use this module. So PS list, I'm going to remove this one. And type Windows in vars. All right, let's filter these results to -p 24 or let's -pid PID 2464. Yep, let's see here. So these are the environmental variables for the 2464. Let's look for environmental variable here. Seems like we have many. So I'm not sure what is the correct answer here, but we have the answer format is very simple. I have to find out. Update app. Let's look again through these results. See, we have data. This is path, com program files. Let's see this. I'll look at this one. I don't understand it. Set OA no cache function. So disables the BSTR caching. This function has no parameters. Caches the space allotted for BSTR strings. The set OA no cache function immediately disables the OL DLL, PSTR caching mechanism. All further locations and deallocations are passed directly to the process allocator. Cached PSTR values are not released. This function should be called before any PSTR by setting the environment variable to on. Oh, so there's a chance that the environmental variable has been set to this one, which is the case actually. Let's look at this one, fp no host check. This is probably not the place for this question, but unfortunately I don't know where it is. Hopefully someone has an answer. Not clear. What sets variable? So this is also an environmental variable. Okay, all of these are environmental variables, but the answer should be either fp no host check or OA no cache based on the answer formula. If I look here at the answer formula, see it's one word. So most probably it is this one. Okay, that concludes the challenge, but there was only one thing that I couldn't get, which is the shell bag. The shell bag plugin, I couldn't find it in Volatility 3, but you can find it in Volatility 2 and invoke the plugin from which you can find the last directory that has been accessed by the user. Okay, that concludes the challenge for today. See you in the next video.